Recording time is up. Good morning, everybody. Welcome to today's webinar. In these days, we are mostly doing webinars, as you know. So this is Bosch Communications webinar, another one for key accounts all over EMEA. And this one, we will talk about PRAESENSA System Design Basics and Offer Preparation. For your information, this webinar is being recorded. Questions will be answered in the end of the presentation. And before we are distributing the slides to your side, we will also add question and answer sessions. So you don't need to write or note anything if you don't like. You can send your questions during the presentation using the chat function on the left-hand side. And then you simply click to the chat button, write your question, and send it to us. Let's make it interactive. I myself will present today's webinar, and we prepared all the slides together with my colleague from Italy, Luca Galli. Also, Peter Opai and Anton Thielen is here for your advanced questions. So let's get it started. Today's objective is to understand system design basics and learn important points to consider during a PRAESENSA offer preparation. I know sometimes sales and project teams needs some support to fully understand a new product portfolio. Sometimes it might be hard during busy days. You learn something new. So we really hope that this presentation helps to you to prepare offers faster than before. And today's agenda, we will shortly talk about the main components and the basics of design. Secondly, we will go through the points to consider to prepare an offer, the most important points to remember during an offer preparation. And finally, we will show a small project example that you can see daily with PRAESENSA. Let's go through the main components. You will also remember from the first presentation, the commercial one, we went through the products. And here is a reminder for that before we start. We, of course, have a controller, a PRAESENSA controller. It's the traffic cop of the system, knows everything about the system, manages the audio routing, just like we have in our other systems like Presidio. We also have a controller here. We have two types of amplifiers, 8-channel and 4-channel. Both are 600 watt, as you will remember. We have a multifunctional power supply. We will also go into the details because this device has a lot of different functions than being a power supply. And we have two types of call stations, the desktop and the wall mount version. These are the main system components. We also have accessories. We will not go into the details in that presentation. But before we go into the connections and the system design basics and then offer preparation details, I really would like to show you the rear side of the devices. I think it will make things much clearer during our discussions. Here you see the system controller. PRAESEL stands for System Controller Large. This device is able to manage more than 100 Dante channels. And as you see in the picture, we have 5 network ports with no PoE output in this device. Here is the VGO symbols. We have VGO symbols for each and every component of PRAESENSA system. You can find these drawings on PRAESENSA micro website, where you will find the link in the last slide of this presentation. And as you see, this is the front side of the device. We have an SD card on the device. It can go up to 32 gigabytes. And on the left-hand side, here I will show my mouse. Here you see 24 volts power inputs. Going into the amplifiers, here we have 2 times network ports no PoE output here. And it depends, of course, if you're using 8-channel or 4-channel amplifiers, then we have 8 or 4 loudspeaker outputs here. And then we have a dual 48-volt power connection for each device. Plus here, we have something called Lifeline. You will also remember this. It's a connection in between multifunctional power supply and amplifiers. It's an analog audio line. In case the Omnio interface fails or the Ethernet network is lost, this connection will take over and will make you able to send your announcements and your messages across. This is the visual symbols for the amplifiers, and this is the front side. When we come to MPS3 unit, as you see, we again have 5 network ports. But this time we also have 2 PoE ports. The first one and the second one is always PoE. And we have 1 SFP slot on the device. So you can directly connect your fiber connection to the MPS unit without having nothing in between. But one thing you should consider here is, as you see, there's only 1 port. So if you would like to have a redundant connection, you have to consider that you have another SFP port somewhere in the system. It can be another MPS3 unit or any other thing. So make sure that you are satisfying a loop there if you need it. Here in this device, yes, it's a switch like we show with the yellow mark here. But it's also a power supply for 3 amplifiers. You see here, this is for the first amplifier, second amplifier, and third amplifier. Powers up 3 amplifiers. That's the reason why we call it MPS3 actually. And then it's already also a power supply for system controller. So sends a 24-volt dual connection to system controller. And as you see here, it's also a battery charger. That's the reason actually why we call it multifunctional. So it's not only a power supply, but also a lot of different functions. And last but not least, you see control inputs and outputs right here. Visual symbols again, and the front panel. Call stations is of course one of the major components of PRAESENSA. We also have 2 RJ45 connections, the Omnio ports in the call station. And then we also have, you will see here in the picture, a 3.5 millimeter stereo mini jack input on the call station. Again, the visual symbols are available. And when you connect all main components to each other, the very basic PRAESENSA system looks like this. So this is the network connection part. Starting from amplifiers, goes to MPS unit, and then from MPS unit it comes back to controller. So we have a loop there, as you see. And in this example, we were using 2 call stations, so they are both connected with PoE to the MPS unit. That could be 1 call station connected redundantly. Also, that's also possible. It depends to your scenario, but this is how it looks in a very short. This is the power side. As you see, the yellow cables, the light yellow, is carrying 24 volts from MPS unit to the controller. The orange cable carries 48 volt from MPS unit to the amplifiers and feeding 3 amplifiers here. And battery is also connected to the battery charger part of MPS unit. Of course, it's not mandatory. If you need it, if you are setting up an EM54 system, then maybe you want to use batteries. Otherwise, it's not mandatory. MPS3 can also work without batteries. If you are doing a rack with PRAESENSA, this is how it will look like. So the controller and an amplifier comes. Here we have 3 amplifiers, as you see. That means we have to have at least 3 MPS units. And we always advise you to install MPS3 units lower part of the cabinet. And then finally, the batteries connected to MPS units, one for each. Please remember that PRAESENSA can work centralized, like we see in the example right now, or decentralized. And also remember that if you are going for the decentralized solution, you don't need to put controller for each and every section, because now all the devices are IP, and now it differentiates, for example, from Presidio or traditional PA one-to-one PA systems in the market. So then you save a lot of controllers there. Please remember that. By saying that, let's go to the points to consider for offer preparation. Maybe you would expect me to start from the controller, but actually I will start from the amplifier quantity, because amplifier quantity is very important and can trigger a lot of different parameters during the offer preparation. And of course, to understand amplifier quantity and to calculate it, the first thing we have to know is how many loudspeaker zones do you need? And of course, what are the power requirements for each zone? One thing here again differentiates PRAESENSA. As you will remember from the first presentation, again, we are using effective power utilization. So PRAESENSA is able to use a very smart power sharing function that you don't have to care about each and every loudspeaker zone and what kind of amplifier channel you're using for that particular zone. As you will remember, in the direct topology systems, in the traditional ones, generally we write down all the loudspeaker zones and then we will try to find out the right amplifier channel for each zone. And then we will multiply or sum up how many amplifier channels and how many types we're using, and then we will come up with a decision how many amplifiers we have to use. Here in PRAESENSA, it's much more flexible. As there's a smart power sharing, you don't have to take care individually the loudspeaker zones. The only thing you have to make sure is that total power per amplifier is below or is equal to 600 watts. It doesn't matter if it's an 8-channel amplifier or 4-channel amplifier, both supports 600 watts, but it's just a matter of choice. So you have to choose which one makes more sense to use 8-channel or 4-channel amplifier, depending to your scenario, locations, or number of loudspeaker zones. So that's the first thing you have to decide, the power per zone. You have to check the total power per amplifier, and then you have to decide which type of amplifier you are using. After this, you have to make sure overall system requirements, the required power is less than the total power amplifier, for sure. That's a general rule, right? So after you decide your amplifier channels, it's always good to check that you are good with total amplifier power also. Always remember that you have an internal 600 watts per amplifier channel inside the amplifier now. If you are using a 8-channel amplifier, there's always a 9-channel inside. If you're using a 4, there's always a 5th channel inside that will support you as a spare amplifier. So you don't need to add additional hardware, additional amplifiers to your offer just to satisfy spare amplifier part. So as you see, in the first time we were talking more commercially, more theoretically. Now these are the real examples how these functions is affecting our lives and cost of ownership for the system. For details about amplifiers, please always remember to complete PRAESENSA expert and master level trainings. Here is an example about amplifier selection. Let's assume that we have 5 zones of 60 watts, 3 zones of 90 watt, 3 zones of 120 watt, and maybe a zone of 200 watt where, for example, you can use hemidirectional loudspeakers or those kind of things. I think very possible scenario in our daily lives. We can easily see such example. So here, of course, it makes sense to use one 8-channel and one 4-channel because we don't have any problems with the power here. and we have to have 12 zones in total. So an 8-channel and 4-channel fits perfectly. So if you can draw it quickly on a piece of paper, so 60 watts here, 90 watts here. So the first amplifier will be 540 watts required and can do 600 watts, so no problem here. And then the 4-channel amplifier will be loaded like this. So it will be in total 560 watt. After you figure out how many amplifiers and what kind of amplifiers you want to use, the second question is to figure out how many MPS3 units you have to have. The critical question here, the most important one, is of course how many amplifiers you have, because the MPS3 unit can feed up to 3 amplifiers. So that's the first question. Secondly, do you have any scenarios to create by using control inputs and outputs? Opening a garage door, triggering something in any other system, or something like that. Any scenarios defined by end user. So make sure that you have enough input and outputs for that, because one MPS3 unit contains 8 supervised control inputs and 8 control outputs. So if you need more than that, maybe you should consider some other options or adding another MPS unit. Thirdly, how many call stations you will connect to this particular MPS3 unit, or overall to your system. Both you should consider. An MPS3 unit has 2 network ports with 1 GB with PoE. So if you want to feed your call stations via that connection, and you always have to consider if they will be redundant connections or just regular connections, because if it is redundant, you will need 2 PoE ports per call station. So then with this calculation, you will figure out if you have enough MPS unit to feed all your call stations. Last but not least, always consider battery management. Because one MPS3 unit can support up to maximum 230 ampere-hour battery. If you need more than that, then probably you will go for a different solution. But this is something you should also consider when you're calculating your MPS3 quantity. So these 4 points is important to go through to decide how many MPS3 you will use. So now in our system, we have our amplifiers and our MPS units. Now it's time to calculate call station quantities and decide what types of call stations we will use. And the right questions to ask: first, how many locations do you have to send announcements from? This is a physical question, and of course you have to decide where the operators are sitting and what kind of rights they will have, what kind of call stations they will use, and from where you will collect announcements into the PAVA system. That's the first thing. Secondly, of course, what type of call stations? Is it a fireman's department? Will you use a wall mount panel, a customized call station, maybe, or is it just a information desk where you will only send business calls? So that these kind of informations will help you to decide if it will be desktop or wall mounted. And then how to power your call stations. Maybe your call stations is close to the center, maybe they are remote. As we asked the question in the MPS3 calculations, do you have enough PoE ports? And yeah, you should consider that. You should at least roughly have to consider and draw that before you prepare and give your offer. The question is, do you want to connect your emergency call station redundant? As said, if so, you will need 2 ports needed. And here, one thing will support you is the PRAESENSA switch, PRAESENSA ES8P2S. And that product is EN54 approved together with PRAESENSA devices. That can be an option for you to increase number of PoE outputs. Or is it possible to use an PoE injector or any other PoE source to power your call stations or your remote call stations? So you can also say that, yeah, I have a call station remote, I don't know, 2-3 kilometers away, and I don't need EN54 at that part of the system, maybe. So you can also consider to use a PoE midspan or any other PoE source, maybe, to feed that remote call station. Or you can consider to add another MPS3 unit if it's a EN54, fully EN54 system, maybe. Last but not least, about call stations, how many call station extension you need per call station that you have to add your offer. Please remember, a PRAESENSA call station always requires at least one extension. So don't forget to add your extension to your offer each and every time you add a call station to your system, at least one. And maximum number is 4. So like in this picture, the small picture you see on the right bottom, you can add 4 extensions per call station. And of course, the buttons are configurable, so you can create different scenarios, or you can just assign a button to a loudspeaker zone for the basic functions. Finally, a number of controllers, controller or controllers. Because, of course, in the system, you at least need one controller. It's mandatory. All systems have to have at least one controller. The question here, do you need redundancy for the controllers? If so, you can add second controller to your offer. And one controller will be defined as duty controller, main controller, you can also call, and the other one will be standby automatically in the system. If you need more controllers, later PRAESENSA system will support more than 2 controllers, so you can always follow developments with your local Bosch teams or your local MKR. And of course, this redundancy will give a good availability, system availability to your PRAESENSA system. Not to forget the end-of-line boards. Supervision is critical, important, and for EN54 applications is mandatory. One of the favorite asked questions when it comes to supervision side, coming from your side to us all the time, was about the pilotons. In PRAESENSA, it's different than the rest of the market. It's inaudible, discontinuous 25.5 kilohertz piloton. So none of your customers will be able to hear this frequency during the supervision. And I said it's discontinuous, so sometimes it comes and sometimes it goes. So it's not continuous, it's not always there, and that's another advantage, of course, about the piloton. By saying that, let's look into the end-of-line board. This is the smallest end-of-line board so far. I would say you see the picture on top. It's really small. And of course, PRAESENSA supports all the known connections about cabling, about loudspeaker cabling in the market today. So during your offer, you should also consider if you will use a regular loudspeaker cabling with one PRA AOL, end-of-line board, per loudspeaker zone, or will you go for A and B cabling where you can need 2 end-of-line boards per one channel, or will you go for a Class A loop, which will not change your change number of end-of-line boards. It will be just like regular, because then you will also use one end-of-line board per loop. But yeah, that's something you should consider to figure out how many end-of-line boards you need. Next step, next question you should ask is the advanced control. This part is optional. Of course, we are satisfying all the voice alarm functions and all PA functions with the main components. And this part gives a big flexibility and a great user interface to PRAESENSA. Is completely optional, but has a lot of features for sure. So do you want to have an advanced public address software, meaning that you have to add a license APAL and a server APAS to your offer? As you see, server is a small computer here for operator, for clients. So not to mix up, I want to say this again, this is not a server that helps PRAESENSA to work or something. This is just for the advanced control side. This is just for the software or user interface side, this server, because sometimes question comes if PRAESENSA will not be able to work without a server or something. This is not related to that. PRAESENSA can work standalone. This server is just for the software part, okay? And then the license will give you a very user-friendly, a very intuitive user interface that the end user or the operator of the system can manage live calls, text-to-speech, recorded messages, background music, can view history. So a part of logging. So of course, as a technical user, you can have a more detailed one, or you can use a logging viewer. And end user can schedule calls here. If you need this, you have to add a PRA-APAL and PRA-APAS to your offer. As said, optional. And then another favorite asked question, and then another thing to consider is, of course, the distances. If you are using a Cat6 cable, you are allowed to go 100 meters. And if you need more distances, then you can switch to a fiber connection and you can go up to 10 kilometers. If you want to reach a subcluster, a system component far away, it can be an MPS3 amplifier, call station, or anything. And if it is away more than 100 meters, then of course you can switch to fiber. With all this information in mind, of course, this is just for the main system components. Your offer can be richer by using some other accessories. There can be some different scenarios that maybe sometimes it will be hard to figure out. The system can be complicated. In these kind of situations, as you know, you can always contact Bosch, and we will try our best to help you with the system design. So you can always contact your local Bosch colleagues for these kind of applications. Let's go through a simple example, considering all the information we had so far. A very daily project we select here for you. It's not that complicated. It is something that you can easily see. Let's say we have a customer need 20 zones of 50 watts. 2 call stations will be used with 12 buttons, and they want to have 2 music sources. The solution here will be 3 amplifiers, because 3 8-channel amplifier can create 24 zones. So we are covering 20 zone request here. And then to feed that amplifiers, that 3 amplifiers, of course, we will need an MPS unit. 1 is enough because we have only 3 amplifiers here, and we don't have any other complicated scenario that will make us out of control inputs and outputs. We will use 2 call stations as requested. Here we choose the desktop ones apparently. And we remember to add extensions to our offers because each and every call station requires at least 1 extension. Remember that? And then they have two music sources, and maybe it's better to have an audio input device because some music sources cannot directly send Dante channels, right? Maybe they are analog audio, so we have to have a converter in between. So our system will look like this. As we talk, the controller, 3 amplifiers, and the MPS unit. MPS unit is giving power to controller and the amplifiers. Blue connections are the network connections. So as you see, each and every component are connected to each other. The main components are completely redundant there. Then we have taken another connection to analog to Dante converter. That device, you can see PRAESENSA data sheets. You will get a lot of advice about those devices there, and you can also always ask us what kind of devices we have tested so far. There's a lot of converters in the market, and the most known ones we are testing with PRAESENSA. And then 2 call stations is connected to the MPS unit with 1 connection, just regular wiring there. So this is how it will look like, a very simple, a very daily PRAESENSA system design, PRAESENSA offer. This is a useful link. I have also shared it before, but here I also add this micro website. Please visit PRAESENSA website. There's a lot of content you will find, all the drawings, all the data sheets, all the software you can download. As said, we will share the slides with you, so you will also have this link. Now, it's time for questions. I already see many questions here.
Yes, we have different questions. The first one is, can call stations be connected as daisy chain? I already answered by chat. The answer is no, because of different reasons. First of all, because call stations are powered by PoE, and you cannot transmit PoE in a daisy chain way. And the other reason is that you have to comply with also with the EN54. So call stations are thought to be connected directly to the MPS3 and powered by MPS3 with a redundant power supply. And then I don't know, Peter, if there are some other reason we can explain about it, you are free to answer, of course. Otherwise, I will go to
the main reason is that you cannot look through PoE via a call station.
Correct.
So that's the main reason why we cannot look through.
Okay, so the second question is always about call stations. 100 meters is the max length allowed to connect call station via cut cable. Yes, because we have to comply with the network, the Ethernet rules. If you need to go more than 100 meters, you have to use optical fiber and maybe put another MPS or a switch, Advantech, especially if the call station must comply with the EN54 in order to use optical fiber. Then can I create a loop circuit with controllers for EN54 purposes? In this case, if the meaning is to have a redundancy in terms of connection, it is possible with PRAESENSA to set up an RSTP configuration, so a loop configuration, and you have to switch on this facility in the configuration software. There is the page where you can set up the RSTP application. About UL boards, do we need any return wire? No, it's not needed because it's wireless as UL, so you only have to connect the UL board at the end of the speaker line. Nothing more is needed. And okay, this this one, or is not possible to create a ring? We already answered, I think. Regarding to amplifiers, also a ring should be offered, in my perspective, to ensure connectivity. We have to keep in mind that each device is IP native, so we should think about a real network. That's why we can do RSTP connection, so we can do loop. We have to take account of the hop count number that are the jump from one device to the other. But in general, yes, we can do a redundant connection of the items. Another question, can you please explain on the decentralized system with the controller and amplifier in the network with switches? Please explain its possibility. This is not really clear. Decentralized system with the controller and amplifier in the network with switch. Yeah, I don't know. Peter and Anton, if you can answer this question, because I think it is related on how to use optical fiber and at this point the switches, and it's
more related to it's more related indeed to network design, and we have also the Advantech switch, which we have as part of the EN certification, which you can use to connect and to set up a network from a central point to these distributed locations. And from there, together with the MPS, they could then via fiber link up to a central point. What is not yet there at the moment is a central switch which has many SFP ports, but we are currently working on that to have such switch also in the certification, that you can create a star wiring from a central point to all the different distributed racks. But still, as long as you, what just was said, as long as you take into account to not exceed the hop count of 22, you can also create multiple loops to interconnect between each other and set in this way up your system distributed.
Yeah. Perhaps I can add something to that, Luca.
Yes.
Everybody has seen the Visio symbols already, yeah? So what I can do is quickly show you what it looks like, and also when you're using fibers. Is that perhaps an idea?
Yeah.
Okay, let me do that. I'll start with a rather simple design. Yeah, we have that already from the last webinar. And you see a Visio drawing now with all the Visio symbols. And what you see is the system controller here on top. You see the amplifiers on the right side, the MPS and the call station. And you see that we were talking already about the loops that we have. This is a loop from the system controller via the amplifiers, via the MPS, and back to the system controller. And this is a loop, and the hop count, and the hop is every unit is a hop, shall not be more than 22. Yeah, so starting with the controller plus 9 amplifiers is 10, 11, 12, 13 hops. And the maximum you can have in a loop is 22. Yeah, so this is a network design for amplifiers and MPS. And what you also see is here that Advantech switch, ES8P2S, what Ozan already mentioned, where we have a lot of PoE ports, where we can connect a lot of call stations, for instance. Yeah, so this is a setup of a system. Now, let me show you something with glass fiber in between. So I'll select another drawing, and that is this drawing, and that is a drawing that is much more complicated. You see already, if I zoom in a little bit, you see the system controller on top. You see then the Advantech switch 1 and 2. Advantech switches have fiber ports. These are two. The system on the left is a remote system The system on the right is a remote system, and you see that we have glass fibers going to the system on the left and to the system on the right. Yeah? And also here we have redundant loops from the controller via the switch, via glass fiber, via all the devices here, and back to this switch and back to the controller. And also this loop should not have more than 22 hops. That is also something that is very important. Always keep that in mind. The maximum number of hops is 22. So I hope this explains the network a little bit very quickly. Yeah, so now we can go back to the presentation.
Yep, thank you very much, Peter. So Luca, maybe we can continue.
Yes, okay, so we have a question with, can this system be connected to interpretation, translation, radiators, and delegate stations? It depends on what we mean as connection, because it's not a conference system, but since he can manage Dante channels, can receive Dante channels from the externals, so from third-party equipment, and can send out up to 8 Dante channels to remote systems. In total, PRAESENSA is able to manage 120 Dante channels, so 112 as an input and 8 as an input-output. This equipment comply with the EN54? Yes, of course, is EN54 16 certified. And can the standby controller be located in a different place than that of the duty controller? I would say the answer is yes, you can do it, following the rules of the network. So if it's within the 100 meters, you can use Cat5. Otherwise, you need to use an optical fiber connection by adding, MPS3 that is needed to feed the controller, or by using Advantech switches. Okay, and last one, I would like to receive these 2 network examples, so we should arrange Peter something to to share, but
yeah, that's no problem.
It's okay, yeah, we can do it. Any other amplifiers available less than 600 watts for small project? Not today. Today we have the model we explained, so the 8-channel with a total value of 600 watts, or the 4 channels with 600 watts. That's total power.
4 channels
yeah,
to come soon.
4 channel, yeah, 4 channel will be available soon. Yeah, correct. Thank you, Zan. And okay, no other question I see. So no more questions. Yeah. Where can I find more information function on the advanced public address license APAL? I think we will be able to release more info in the next month, because when he's not yet released the APAL, and we will have more info, I assume, in the next month. And that's it. Okay.
Okay.
So I think we could close, Rosanna.
Yeah, there's no any other question, I believe. Thank you very much for your time and interest. Thank you very much for being here. That you can always reach us and your local Bosch responsibles for any kind of question. We wish you a great day. Thank you very much. Stay safe.
Yeah, the last question, where we can download the webinar. So I think.
Oh, yeah, that's a good question.
Sorry.
Actually, let's mention that. That's a good question. We will distribute the slides. So we will now add all the questions that you ask here in the chat box. We will also add them as slides. And there was another request that we add the drawings Peter mentioned. So we will give a last shape to those slides, and then we will distribute them to you, to the participant list. I hope this answers
Yes.
the question. Okay. Thank you very much.
You.
Stay safe. Have a great day.
You too. Bye. Bye. Bye.